Yes. Now started. Okay, electrostatic. So just we will revise yesterday's part. So this electrostatic, the concept of electrostatic is invented by the scientist Coulomb, and so there are two laws which are related to the static charge. That is, the first law is like charges repel each other and like charges attract each other. Second law is the force between these two charges is directly proportional to the product of magnitude of charges and inversely proportional to the square of the
distance between them.
Yes, exactly. Distance between them. These are the two laws. Next concepts are the we have covered electric flux. Electric flux, that is psi. Next is the electric flux density. Yeah, it is B और क्या हुआ था? Intensity. Electric field flux of the intensity is E. Okay, और कुछ बचा है? Permittivity. Permittivity is denoted by epsilon. Okay, epsilon permittivity. For the relation of the ये relation फाइंड आउट किया ना और कौन सा था बता फर्स्ट करेक्ट d is equal to epsilon e जैसे मैग्नेटिक सर्किट में p is equal to qh रहता है इसे यहाँ पे d is equal to epsilon e करेक्ट एनीथिंग एल्स मैं राहिला का बघा हेलो हेलो am I audible
Yes, ma'am.
Yes, ma'am.
बता ना फिर हाँ ये epsilon का यूनिट मैंने बताया
मैम
कि जहाँ पे यस
मैम वो साई है ना, वो इलेक्ट्रिक फ्लक्स का साई.
हाँ यस
वो साई है ना.
हाँ ये साइड इसको इस साइड बोलते हैं मैंने बताया था ना कि कल मैं बोर्ड पे एक बार से काम किया तो बताया दिस इज साइड इलेक्ट्रिक फ्लक्स का कंडीशन है दिस इज नॉट द साइड ओके कूलम इसमें यूनिट क्या है कूलम क्लियर
Yes, ma'am.
ओके नाउ नेक्स्ट जो पार्ट है वो कैपेसिटर और हाँ ये भी है कैपेसिटर कैसे डिफाइन किया जाए कैपेसिटर capacitor bata it is the electronic component which is having the capability to store the charge right yes exactly and it consists of the two electrodes it consists of the two electrodes which are separated by the dielectric material which are separated by the dielectric material which is acting as an insulating material. One of the plate is positively charged and another plate is the negatively charged. Okay. Now next relation क्या था? यहाँ पे एक relation आया था. Charge store on the capacitor. जो capacitor के ऊपर charge store होता है, that is directly proportional to the applied voltage. Okay, that is directly proportional to the applied voltage, and hence, if I remove this proportionality sign, it becomes C into V. Therefore, the C is nothing but Q. This is the relation for capacitance. Clear? Okay. Reply
Yes,
करो.
ma'am. Yes, ma'am.
ठीक है. Now
Yes,
next
ma'am.
one, next part आता है capacitance of parallel plate capacitor. मींस ये तो हमारा एक सिंपल सा रिलेशन हो गया, लेकिन जो कैपेसिटेंस की वैल्यू है, कैपेसिटेंस की वैल्यू वो एरिया के ऊपर डिपेंड होती है, इन दो प्लेट्स के बीच में जो डिस्टेंस होता है उसके ऊपर भी डिपेंड होती है. So we have to calculate that value. Capacitance of parallel capacitor. See, for this we have to consider one capacitor. Okay, consider okay. One of the plate of this capacitor is positively charged, and another plate is negatively charged. Let the distance between these two plates is d. Consider the distance between these two plates is d. Next, please consider this is the dielectric material. It is having no permittivity of epsilon r. Okay, relative permittivity क्या है material की epsilon r. And suppose the area of this plate and this plate is a square. Small a or capital A जो आपको चाहिए वो कंसीडर कर सकते हैं. ठीक है. So first you have to explain like this. Consider the parallel plate capacitor with two plates. One is positively charged, another is negatively charged. Distance between the two plates is d meters, and area of each plate is a meter square. The relative permittivity of the dielectric material between two plates is epsilon r. Any doubt in this diagram? Is there any doubt?
No, ma'am.
Now, all of you know that whenever we are giving the supply to this capacitor, there will be the production of electric flux, and that electric flux is equal to the charge stored by that capacitor, and it is nothing but Q. Is it correct? ये तो हमें पहले पता है. Whatever electric flux is there, that electric flux is nothing but the charge stored by the capacitor. ठीक है? Consider this relation as a one. Next, electric flux density D is nothing but the flux divided by area. Electric flux density is given by the flux divided by area, but this flux is nothing but the Q. From equation 1 we will get it is the Q divided by A. Psi divided by A is equal to Q divided by A. Next, D is nothing but epsilon E. Is it correct now? D is nothing but epsilon E, right? D is nothing
Yes.
but epsilon E, but E is what? Electric field intensity का formula? V divided by
D.
D, exactly. V divided by D. So what we will get? We will put all these values in this equation. We will get D is Q by A. Okay, Q by A is equal to epsilon remains as it is. D is equal to G divided by D. Okay. Now I will rearrange this equation. So what is equal to epsilon A. ओके, यहाँ पे किधर C आएगा क्या अभी बताओ? C आ सकता है यहाँ पे कहाँ अभी? C એટલે कहाँ? बताओ? कहाँ पे?
Yes, ma'am.
Left hand side is what? P. Q1 is nothing but C ना? So is equal to epsilon 0 epsilon r cube d. So this is the capacitance of palliated capacitor. Is nothing but epsilon 0 epsilon r a divided by t, where you can say that the capacitance is directly proportional to area of plate, but it is inversely proportional to the distance between plates. Is it clear? See start to end देख लो एक बार. बताओ किसी को कुछ डाउट है क्या? Okay. Okay.
Yes, ma'am.
Yes, ma'am.
Okay, see, there are 5 to 6 students in our class who have not submitted experiment number 1 and assignment number 1. ये submit नहीं किया है, ठीक है? So you have to submit it. जिन्होंने नहीं किया है, लेट मार्क तो आपको मिलेगा ही, क्योंकि जो जहाँ पे आप सबमिट करते हो गूगल क्लासरूम में, वहाँ पे ऑटोमेटिकली लेट सबमिटेड करके ऑटोमेटिकली मार्क आते हैं, ठीक है? So लेकिन सबमिट करना है, otherwise you will get 0 marks. और ये हो गया capacitance of parallel capacitor. Now next जो relation है, very simple relation. Capacitor in series and capacitor in parallel. Take a series. C1, C2, C3. This is the supply voltage. Consider I is the current going through this series of capacitor, and I have to find the equivalent capacitance of this combination. Okay. Consider this is CS. Okay, you know the combination of CS. Now, please tell me, in this combination, current will be same. Is it correct? Current will be same, na? Series combination है तो? Yes, na? Hello?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Current will be same. C1, C2 and C3 के ऊपर charge same रहेगा क्या? बताओ. Charge will
हाँ,
be
ma'am.
same. Yes, charge will be same. C1, C2, C3 के ऊपर जो charge रहेगा, Q, same thing. Okay, and voltage across each capacitor will be
Different.
yes, exactly. V1, V2, V3. Right now, V1, V2 and V3. So, यहाँ पे V1 is equal to क्या आएगा? V1 is equal to बताओ. V1 is equal to
Q1
Q upon C1.
Q1 नहीं, Q upon
C1.
C1.
C. But this total voltage V, will be addition of
V1 plus V2 plus V3.
ये तो standard में आते हैं हुआ है. फिर भी आप इस तरह से दिए हैं, so therefore ये भी जो है हम क्या लेते हैं इसको Q divided by C is equal Q will get cancelled and you will get 1 upon CS C Is it opposite to resistance combination, right?
Yes, ma'am.
Yes,
Yes.
na? So whenever the resistances are connected in series, the equivalence is same,
Direct
R1
R1
plus
plus R,
yes,
R2
R1
plus
plus
R.
R2 plus R3. But in case of capacitance, it is opposite. Okay. Now next we will conduct for okay. Next is the series combination. Series, sorry, parallel दिखते series हो गया. Next will be the parallel. Parallel. Like consider capacitors are connected parallel. Now, in this case, the charge on each capacitor will be different, right? Charge on each capacitor will be different. Is it correct?
Yes.
Yes.
Q1, Q2, Q3. Current I1, I2, I3. And but the voltage across each capacitor will be same as those are connected in parallel. Okay. Now we can write here the total charge stored will be Q1, Q2 plus Q3. Total charge stored on capacitor will be Q is equal to Q1 plus Q2 plus Q3. Okay. So Q is nothing but what? Multiplication of C into V, right? So yes, C into V. So but here this Q will be the combination of all capacitors. Yeah. C1 into V plus C2 into V plus C3 into V. They will get cancelled and parallel capacitor will be addition of all capacitors. Correct? ठीक है? समझ में आया? Any doubt? Is it okay? Please reply.
Yes,
64
ma'am.
students are there. Only 1 or 2 students are answering. ठीक है. Now next part आता है capacitance of parallel plate capacitor with composite dielectric. Okay, now what is the meaning of this composite dielectric? Nothing but अगर कैपेसिटर में डिफरेंट टाइप्स के डाइलेक्ट्रिक मटेरियल है तो उसका कैपेसिटेंस कितना आएगा, ठीक है. We will draw the diagram first and then we will start. Capacitance of parallel plate capacitor. Okay, देखो डॉट गेट कंफ्यूज. पहले हमने फाइंड आउट किया कैपेसिटेंस ऑफ पैरेलल प्लेट कैपेसिटर, ठीक है, सी का फॉर्मूला. नेक्स्ट कैपेसिटेंस in connected in series and when connected in parallel. Next capacitance of parallel plate capacitor with composite dielectric. I will draw the diagram, then get the idea what is it by the composite dielectric. Okay. See. Here there are 1, 2, 3, 4 plates. Okay, and these 4 plates are forming the combination of 3 capacitors, first, second, and third. Now suppose in this capacitor the dielectric material is different. Okay, we are again consider use the dielectric. Suppose epsilon R1, epsilon R2, epsilon R3. ठीक है, epsilon R1, epsilon R2, and epsilon R3. Next, हमें डिस्टेंस भी चाहिए यहाँ पे. कंसीडर D1, D2, this is D3. Okay, D1, D2, and D3 distance between the plates. And next, now please tell me this combination is looking like series combination of capacitor or parallel combination of capacitor. बताओ.
Series.
Yes, exactly. This is like a series combination of capacitor, and as these are connected in series, area of each plate must be same. ये area of plate क्या रहेगा, same रहेगा. सिर्फ distance अलग हो सकता है. So this is equivalent to C1, C2, C3. Series. Now all of you know that when they are connected in series, at that time the equivalent capacitor is 1 upon C is equal to 1 upon C plus 1 upon C2 plus 1 upon C3, like that. Is it correct? C1 plus C2 plus C3. Now, what will be the value of C1? What will be the value of C1? अभी जो हमने लास्ट फॉर्मूला डिराइव किया उस फॉर्मेट में C1 की वैल्यू क्या रहेगी?
A epsilon
R
naught
E upon D1.
Epsilon naught, epsilon R1, A
upon D1.
Similarly, C2, C3. Now, pull down the all values in this equation. So, अगर वैल्यू आप पुट करते हो C1 C2 1 upon C लिख दिए 1 upon C D1 divided by epsilon 0 epsilon r1 a epsilon 0 epsilon r2 a and third one. Okay. Now suppose I want C. C कैसे कैलकुलेट करोगे बेटा? C अगर चाहिए तो बताओ. हेलो.
I am taking 1 upon epsilon, not a common.
समझ में आया फॉर्मूला?
Yes,
Okay.
ma'am.
So this is the all about composite.
मैम ऊपर D1 D2 D3 रह गया
ऐसा
मैम.
क्या हुआ?
Oh, sorry. Okay, fine. Only common will be epsilon 0 into A. And hence the composite capacitor का जो capacitance है that will depend upon the type of material. Okay, permittivity का कौन से material के ऊपर depend है? Type of material and the distance between the plates. Distance between the plates will vary हो रहे हैं. अगर material change हो रहा है, then value of capacitance will get changed. Okay, ठीक है?
Yes, ma'am.
Yes, ma'am.
यहाँ पे अगर CS करना है तो कर सकते हो. CS करना है तो कर सकते हो.
Reciprocal.
Reciprocal ले सकते हो. ये वाला नीचे आएगा. D1 divided by ऐसे भी लिख सकते हैं. करेक्ट ना? है ना?
Yes, ma'am.
Yes, ma'am.
Yes. Very simple. So find it. Keep in mind this one. Okay. Any doubt? Any doubt?
तुम्ही इथंच बसा, मी तिकडे बसतोय आता थोडे.
No, ma'am.
डिस्टर्बन्स नको.
Swapnil.
Yes, ma'am.
Swapnil को घरात त्यांना ओरडतो. Okay, ठीक है. परत झालंय. The next last एक part आहे. Last नाहीये, last part. Energy stored by capacitor. Stored by capacitor, which is also known as energy stored by electrostatic field, which is also known as energy stored by electrical field or electrostatic field. ठीक है. And what was the formula for energy stored by inductor? क्या था formula?
Half Li square.
Half Li.
Half Li square, and which is also known as the energy stored by magnetic field. Okay, दोनों का मतलब same. ठीक है. So for finding the energy stored by the capacitor, we have to consider the capacitor of C Farad. ठीक है. Consider करो कि एक capacitor है और वो उसकी वैल्यू कितनी है? C Farad है, and it is to be charged at a potential difference of V volt. ठीक है. See, एक capacitor consider करो. Okay, उसको it is to be charged so that ये दोनों जो प्लेट है उन दोनों के बीच में पोटेंशियल डिफरेंस कितना होना चाहिए? देखो एक प्लेट पॉजिटिव हो जाती है, आप इसको सप्लाई देते हैं, ठीक है? Then it gets charged and hence one will be positive, other will be negative. So इन दोनों के बीच में क्या हो जाता है, पोटेंशियल डिफरेंस हो जाता है, ठीक है। सो ये क्या बता रहे हैं आपको कि कंसीडर द कैपेसिटर ऑफ सी टाइप इज बी चार्ज सो दैट उसको चार्ज करना है so that the potential difference of between the two plates will be the V volts, ठीक है। now all of you know that कि आपने कैपेसिटर को अगर सप्लाई दिया, आपने कैपेसिटर को अगर सप्लाई दिया so immediately it will not get charged, okay। कुछ तो फ्रैक्शन ऑफ सेकंड आपको लगेंगे चार्ज होने के लिए, लेकिन इमीडिएटली जीरो विद इन 0 मिनट वो fully charged नहीं होगा, ठीक है। so what we have to consider the capacitor charged at small q charge at any instant of time, ठीक है। अगर मेरे पास एक कैपेसिटर है और अगर आपको बताया कि 1 मिनट बाद वो फुल चार्ज होता है, ठीक है। अगर आपको पता है कि 1 मिनट उसको लगती है चार्ज होने के लिए, तो मैंने क्या किया बिफोर 1 मिनट, ठीक है, कुछ तो आधे मिनट के बाद ही मैंने उसका चार्ज मेजर किया एंड सपोज वो चार्ज कितना है q, ठीक है, उसको मैंने स्मॉल q कंसीडर किया, फुल चार्ज के लिए कैपिटल q कंसीडर करो। सो सप्लाई वोल्टेज उतना ही होगा, ठीक है, कैपेसिटर की वैल्यू उतनी होगी, लेकिन चार्ज कितना है उसके ऊपर स्मॉल q है उस टाइम। समझ में आया यहाँ पे ये मैंने इक्वेशन क्यों लिखा, समझ में आया क्या, प्लीज बताओ, समझ में आया क्यों ये लिखा मैंने, क्यों at any instant of time during the process of charging at any instant of time let the charge of that capacitor is small q coulomb, means वो fully charge नहीं हुआ है, उसके पहले मैंने उसको मेजर किया, ठीक है। now while charging there is an electrical work done, okay, while the process of discharging there is the electric work done to shift this charge from one point to another point। ये charging की process जब है, जब charge यहाँ से यहाँ तक हो रहे हैं, at that time there is an electric work done and as we have considered the small charge, okay, एक छोटा सा charge consider किया है, so consider the small work done, okay, इसके लिए work done भी क्या consider किया है dw, small work done, and it will be this fraction of charge, okay, dw is equal to q into dq, but what is the v value of v, divided by c, okay। see मैंने क्या किया यहाँ पे, एक कैपेसिटर है उसको मैंने वोल्टेज भी दिया है, उसका कैपेसिटेंस c है and the process of charging is going on and while the process of charging is going on मैंने before the full charge मैंने उसके पहले ही उसके ऊपर का चार्ज मेजर किया and ये चार्ज है small, ठीक है, by using that concept मैंने ये इक्वेशन पर बना दिया। now जो जहाँ पे इलेक्ट्रिकल सिस्टम होती है वहाँ पे इलेक्ट्रिकल वर्क डन होता है। व्हाट इज इलेक्ट्रिकल वर्क डन, इलेक्ट्रिकल वर्क डन इज नथिंग बट टू मूव द चार्ज फ्रॉम वन प्लेस टू अनदर प्लेस, ठीक है। तो वैसे ही एक छोटे से चार्ज के लिए वर्क डन मैंने कंसीडर किया, दैट वर्क डन इज स्मॉल dw इज इक्वल टू वोल्टेज v into dq। सी वोल्टेज में भी फ्रैक्शन नहीं लेते, ठीक है, क्योंकि देखो अगर आपका ये कैपेसिटर है तो कैपेसिटर ये आपका वोल्टेज है, ये आपका कैपेसिटर है, सो अगर इस कैपेसिटर को आपको चार्ज करना है तो आपको फुल वोल्टेज ही देना है, it will take some time to charge fully charge, okay, so after some time it will get full charge, so supply voltage v remains the same। now put up the value of this v in this equation, that is the q divided by c into dq। this is the small work done, मुझे क्या चाहिए total work done। what we will do, total work done
Integrate it.
yes, so it will be and charge पहले कितना था कैपेसिटर के ऊपर 0, फाइनली वो कितना होना चाहिए कैपिटल। ठीक है, इन दोनों के बीच में जो मेजर किया वो स्मॉल क्यू। इज इट करेक्ट? फुल्ली चार्ज मैंने क्या बताया था पहले, कैपिटल क्यू कंसीडर करेंगे एंड हेंस limit we have to take 0 to q. So 1 divided by c. What will be the integration of q with respect to dq dq? क्या
Q
है?
square by 2.
Yes, square. 1 2 क्या आएगा लिमिट पुट करने के बाद पता आंसर
Q square by 2c.
this was the energy stored and now to see is it correct? 1/2 to c into q square. Suppose is by c okay, so क्या आएगा यहाँ पे?
half CV square.
CV square and half UV.
आप c square आएगा so these are the energies stored by the capacitors. Clear? Any doubt? Energy stored by capacitor. किसी को कुछ doubt है?
No, ma'am.
Joules and unit is joules. ठीक है, स्वप्निल रेडी है क्या? आप रेडी हो क्या? स्वप्निल
Yes, ma'am.
एक्सप्लेन कर रहा था, हाँ चलो ठीक है. So now we will conduct the flip next activity, that is the flipped classroom. Okay, and Swapnil is going to deliver the lecture and now I am student. Now I am student.
Can I share screen, ma'am? My screen is visible
Yes.
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 and audio is coming.
Yes.
Yes.
So, good afternoon, all of you. So today we will learn about topic electrostatics. First of all, what is meant by electrostatics? As its name contains, electro plus statics means electric charges which are at rest. So its definition is, it is the study of electric charges at rest. कोई भी चार्जेस जो रेस्ट में है उनकी अगर हम स्टडी करेंगे तो इलेक्ट्रोस्टैटिक्स होता है वो. इलेक्ट्रोस्टैटिक इंडक्शन, नेक्स्ट पॉइंट. It is a method of charging an uncharged body by introducing some charged body near it, and it is also called as redistribution of electric charge in an object caused by the influence of nearby changes. So here negatively charged rod is come in contact with the object. So due to negative charge on the half side, positive charge is developed, as we know the redistribution of electric charges. But to maintain electrical neutrality on the half side, negative charge will also induced. This is an example of electrostatic induction. So next is law of electrostatics. So there are two laws. Coulomb's first law. First law states that like charges repel each other, means positive charges will repel each other as shown in diagram, and negative charges will also repel. But opposite charges when come in contact, they will attract each other. So here positive and negative charge, when they are coming in contact. They will attract each other. Second law, Coulomb's second law. The force of attraction or repulsion between two charged bodies is first of all directly proportional to product of magnitude of charges, and second one is it is inversely proportional to square of distance between both the charges, and third one is it depends upon nature of surrounding medium. So its expression is given by F proportional to Q1 into Q2 divided by D square, where D is separation distance between the two charges. So here F is equals to K into Q1 into Q2 by D square, where K is a proportionality constant. So F is equals to 1 by 4 pi epsilon naught Q1 Q2 by D square. And here value of epsilon naught is calculated experimentally as 8.854 into 10 power minus 12 farad per meter. So the next part is applications based on fundamental principle of electrostatic. So electrostatic painting is the first application. So what is electrostatic painting? So as we know, painting means to paint an body. So here in electrostatic painting, we paint a body, but by the use of electrostatics. How? Here we use a principle that object.
Hello, Swapnil.
Yes, ma'am.
Students are saying कि please rotate your screen. ऐसे बोल रहे हैं. Horizontal करो.
Ma'am, it is not rotating.
Okay, fine. Continue. Mobile वरती आहे ना, so
Ma'am, we can
Can
zoom it.
आप zoom करो खुद से. बाकी के लोग zoom करो. नाही, तू zoom नको करूस. जे आपण मोबाईल वर करू शकतो, जे मीटिंग मध्ये जॉइन आहे ते म्हणा. You can continue.
okay. So electrostatic painting based on the principle that we give charges on the both the objects. If we want to paint one object, so we will ground it, because grounding that object we will give that object negative charge as shown in the figure, and we will give positive charge to the paint. And due to electrostatics attraction, Coulomb's first law, unlike charges will attract each other. When we sprinkle that paint, then it will accumulate on the object and get fully painted with accuracy. So it is an application of electrostatics. Second one is application is photocopier. It also works on same principle. So now we will move to next part, electrostatic field or electric field, the region around a charged body where another body experience a force is called as electric field. So here two diagrams are shown that two equal unlike charges will attract each other, and as we know the property of electrical field lines, that it will start from positive charge and end up at negative charge. So in diagram it has shown, and in two equal like charges they are repelling each other. The next part is electric flux. Electric flux is nothing but total number of lines of force that passes through electric field is called as electric flux, and it is denoted by symbol psi, a Greek word letter, and is measured in coulomb. Electric flux density. Electric flux per unit area measured at right angle to the direction of electric flux is known as electric flux density, and its symbol is capital D, and we will derive an expression as capital D is equals to psi upon A or Q upon A. So next is electric field strength or electric field intensity. The mechanical force experienced by unit positive charge placed at north pole in electric field is known as electric field strength at that particular point. So here and derivation is given as E is equals to F upon Q. Here F is the force acting and Q is the charge, and its unit is Newton per coulomb, and we can derive it as F E is equals to Q upon 4 pi epsilon naught epsilon D square, and E is equals to Q upon 4 pi epsilon naught epsilon R D square. And there is one another formula, capital E is equals to V upon D, where V is the volt and D is the distance, and its unit is volt per meter. So next topic is relation between flux density and electric field intensity. The flux density at any point is proportional to in electric field intensity at that point. Hello?
दोनों परेश भविष्य के पास डीएफए एंड डीएफए
आवाज कुठून तरी
संतोष
येतोय.
पाटील परेश भावेशी आणि शरद चौधरी.
Hello?
हाँ
हाँ ये अगर हो गया ना, हाँ ये हो गया.
हाँ
E proportional to E, D is equals to K into E, or D is equals to epsilon into E, as epsilon is equals to epsilon naught epsilon R. So capital D is equals to epsilon naught epsilon R into capital E. So next concept is permittivity. Permittivity is defined as ease with which the dielectric medium permits an electric flux to be established in it. So there are three types of permittivity. Permittivity of free space, which is called as epsilon naught. The permittivity of free space is the ratio of electric flux density in vacuum and or in free space corresponding to the electric field strength, and its unit is farad per meter. Epsilon naught is equals to D naught upon epsilon, and D naught is equals to epsilon into capital E. Absolute permittivity is denoted by epsilon. The ratio of electric flux density to electric field strength is known as absolute permittivity. Absolute permittivity is dependent on the nature of dielectric medium, and formula of epsilon is equals to capital D upon capital E, and capital D is equals to epsilon into capital E. As we have seen in magnetic circuit, capital B is equals to mu H. Likewise, this is the formula.
ओके. स्वप्निल एक टाइम संपत है आपला. ओके व्हेरी गुड. स्वप्निल ने बहुत अच्छे से एक्सप्लेन किया है ईच एंड एवरी टर्म. फक्त आता एकच राहिली ना रिलेटिव्ह परमिटिव्हिटी, बरोबर ना?
Yes. हो.
व्हेरी गुड स्वप्निल, छान ट्राय केला. सो नेक्स्ट पण असंच काही लोकांनी ट्राय करावा अशी माझी इच्छा आहे. ठीक आहे. वन्स अगेन व्हेरी गुड. ठीक आहे. सो नेक्स्ट अटेंडन्स द्या सर पटपट. नेक्स्ट लेक्चर आहे इथे क्लासरूम मध्ये. रोल नंबर 1
Present ma'am.
yes 2
Present ma'am.
3 लेफ्ट करा होईल तसं पटकन.
Present, ma'am.
4
Present ma'am.
5
Present, ma'am.
6 7
Present, ma'am.
Ma'am, sixth present ma'am, six.
6 7 8
Present, ma'am.
9,
Present, ma'am.
10,
Present, ma'am.
11, 12 present, 13, 13, नहीं है, 14, 14,
Present.
14 कुठे present आहे? 15,
15 present, ma'am.
हाँ, 14 absent, 16, 16, 17,
Present, ma'am.
18,
Present, ma'am.
19, 19, 20,
Present, ma'am.
21, 21, 22,
Ma'am, 31 present.
22, 22, 23,
Present, ma'am.
24,
Present, ma'am.
25,
Present, ma'am.
26,
Present, ma'am.
26, 27,
Present, ma'am.
28,
Present, ma'am.
29,
ma'am.
30,
Present, ma'am.
31.
मैम
Present, ma'am.
22 प्रेजेंट है मैम,
Okay,
नेटवर्क इशू था।
ठीक है, 33, 33,
Present, ma'am.
34,
Present, ma'am.
35, 35 present, 36,
Present, ma'am.
37,
Present, ma'am.
38, 38,
38 present, ma'am.
39, 39,
39 present, ma'am.
40,
Present, ma'am.
41,
Present, ma'am.
42,
42 present, ma'am.
43, 43, 44, 44, 45,
Present, ma'am.
46, 46, 47, 47, 48,
Present, ma'am.
49,
Present, ma'am.
50,
Present, ma'am.
51,
Present, ma'am.
52,
Present,
Present, ma'am.
53, 54, 54, 55, 55,
Present, ma'am.
56,
Present, ma'am.
57,
Present.
58, 59,
Present, ma'am.
60,
Present, ma'am.
61,
Present,
61,
ma'am. Present, ma'am.
62,
Present, ma'am.
63,
Present, ma'am. 63 present.
64,
Present, ma'am.
65,
Present, ma'am.
66,
Present, ma'am.
67,
Present, ma'am.
68,
Present, ma'am.
69,
Present, ma'am.
70,
Present, ma'am.
71,
Present, ma'am.
72,
Present, ma'am.
73. हाँ बोला
14 प्रेजेंट है.
हाँ मी ॲब्सेंट नंबर चॅट बॉक्स मध्ये टाकून